Welcome back to Balance AI. If you've been following this channel, you know we have been building a strong foundation in deep learning. We started with image data. We saw how dense layer capture global patterns and how CNNs capture spatial hierarchies. See, but there's an entire class of data that isn't static like images. Data where order matters. Data where what comes later depends on what came before. Think about stock prices over time. Think about the sentences you just read. These are not static inputs. These are sequence data. And an exciting pivot for us because this is the domain that gave birth to the modern AI revolution we're currently witnessing. Whether it's ChatGPT, Gemini, Cloud, all of them trace back to understanding how AI learns from sequence data. So in this video, I'm going to break down different types of sequence data, the real-world applications behind each one of them. No math yet, no code yet, just crystal clear intuition, so that everything we do next, including the neural networks that will deal with this type of data, will make complete sense. Let's begin. So when it comes to sequence data, there are two types of sequence data that we're going to be looking at. The first one would be a time series. Okay, so what exactly is a time series? Time series, you can think of it as a sequence of data points, like let's say sales data or weather data, that is collected and recorded over specific intervals, usually equal spread, but basically to track changes over time. Okay, so time series, again, it's some kind of data, whether it's sales data, stock price data, weather data, that is collected and recorded with, at different time intervals. Okay, so again, it could be something like this, the temperature data, in this case, maybe you're trying to predict temperature in a city, right? As again, temperature of each day. So maybe we're trying to forecast that. Okay, so it could be a weather forecasting also, or it could be a sales data forecast. So maybe some companies trying to, predict their sales into future. So time series, one of the main applications with respect to time series is like, predicting the future, forecasting. Okay, so it could be data related to that, or it could be simply, a stock price prediction. Like, this is a stock chart of NVIDIA. Again, many of you might be, if you're not, again, you should be familiar with NVIDIA, especially if you're taking this course, because NVIDIA is the company which is enabling this AI, the latest AI revolution with its GPUs, which are almost all critical to train all this, large, huge parameter, AI models, whether it's image models or NLP models, right? NVIDIA is enabling that. Okay, anyway, just wanted to show you what a typical or a sample, time series data might look like. Okay, again, it's data that's recorded over different intervals of time. Basically we track the change of some quantity, over time. Okay. Again, this time series data has many peculiarities related to that, right? It could have some seasonality, some kinds of trends. Okay, so this is time series. What about the applications of time series? Again, there are many different applications, and as already we have been looking at this figures here, right? Forecasting is one of the big application, predicting the future in essence, right? So maybe you can do sales forecasting or stock price prediction or weather forecasting, or we could use time series data like, for anomaly detection. Like maybe we were trying to, monitor some machine sensors and trying to, determine or identify some abnormal patterns in it. Or maybe we want to detect these abnormal patterns, in financial transactions, maybe related to some customers, and try to detect fraud in the process, right? So, or it could be demand forecasting. Maybe we're trying to, predict future demand so that we can optimize our inventory levels, right? Or it could be like economic and financial analysis where, you want to analyze the trends in the economic data and predict different things like GDP, inflation rates or interest rates, mortgage rates. So you can use time series for all such things. Okay. All right. Now let's look at the other type of sequence data, and that would be text or basically human language. Okay. So what are the different types of applications when it comes to text? Again, there are many different applications. The main ones, I just want to summarize few of them. Okay, so the main ones could be sentiment analysis. So let's say we have a review from a customer for some product or a movie. Like for example, in this case, it's a movie. So this was an intelligent blockbuster movie and a solid proof that art house and entertainment doesn't need to be contradictory. So this is some review like by maybe in IMDb. Okay. So given this kind of a review, if the goal is to determine the sentiment, in this case, this is a positive sentiment. So the model, like a deep learning model, should be able to understand this English, right? This language, understand the context, and also the relation between each word and the preceding word. So, like for example, the word contradictory, right? So this contradictory is related to, because it says the movie was an intelligent blockbuster movie and a solid proof that art house and entertainment don't need to be contradictory. So contradictory is related to this art house and entertainment. So there is some kind of a dependence between the words that follow, later in the sentence with the words earlier in the sentence, right? So this kind of a dependence is common with sequence data, okay? Again, this is one application, sentiment analysis. There could be more applications, like for example, let's say translation. Okay, so if you have a sentence, you want a deep learning model or an AI model that can translate the sentence. So if it's English, you want to, like the sky is blue. You can, if you want to translate to Spanish, this is how it would look like. I'm not going to try to pronounce it, and don't offend anybody who speaks Spanish, but you get the idea. Okay. Or text generation. So maybe, again, we want to have a deep learning model or AI model where we can ask it to generate some random passages. Maybe we want to prompt it and we want it to complete it. So let's say we want it to give us like a poem or a paragraph related to, let's say, AI. Okay, so how AI is important in future proofing our careers. Right. So if you want to model to generate something like that, so it will randomly generate, based on our prompt, it can say, for example, this is generated by AI model. You can just say, in a world where AI shapes every task, we seek jobs that will surely last, adapting skills, both sharp and vast, future-proofing careers, so none are outcast. Together we build a future unsurpassed. So this is just something I was asking, one of the AI models, I don't remember now, maybe it was ChatGPT that, you can generate, text like this, okay? Or named entity recognition. It's another extremely important application. So as named entity recognition, so what is this? It's you can think of this as a token classification, right? You're going to classify each word in a sentence. So for example, if you see, let's say you give a sentence like this: Elon Musk founded Tesla in 2003, and it is headquartered in Palo Alto, California. Given this sentence, we want the model to detect different entities in it. Okay, like let's say Elon and Musk is a person, right? And Tesla is an organization. 2003 is a date. Palo Alto is location. California is location. And the other words, they are nothing. There is no particular class for that. So this is kind of a token level classification, and that's called named entity recognition. Okay, all right. Or you could have another application like question answering. Right? So maybe in question answering models, typically to the model, we give both the context and the question. So when given a context and a question, the model should extract the answer for us. So that is called question answering application. So for example, if you have a context, France's capital, Paris, is known for its art, fashion, and culture. So then the question would be, what is the capital of France? And the model should respond saying Paris. So typically for models like this, we give pairs the training data would be pairs of the context and the question. Okay, so this could be a question answering model. Okay, all right. And then there are many more applications. So you could have summarization, language modeling. Again, language modeling looks very similar to text generation, but basically given a sentence like the cat sat on a, and you want the model to complete like wall, cat sat on a wall. Right. Or so basically there could be numerous other applications related to text and language, but these are some of the main ones. Or right now, like, with some of the latest LLMs, right, all this ChatGPT or Gemini, they are doing many of these tasks, right, in a single setting. So you don't, many of the models, AI models right now, you can directly use them for all of these applications. Okay, so just want to give you an idea as to different kinds of applications that are related to sequence data, which is, again, sequence data like text, or when you're talking about human language. Okay, so we have looked at the two main types of sequence data, time series and text. But the idea of sequences goes beyond just these two data types. Sequence data could also be speech, video data, user behavior logs, or even biological sequences. But all of them are data where order matters. And once order matters, something new enters the picture: memory. And that's where neural networks must evolve. So in the next video, we'll explore how we deal with such different types of sequence data. We'll look at RNNs, recurrent neural networks, to LSTMs, to the transformer architecture that powers the modern AI systems. So see you in the next video. Happy learning.